Okay, this is chapter 3.3, proofs with parallel lines. Oh, proofs. Oh, here. I need to adjust and get prepared for this. Proofs. Essential question. For which of the theorems involving parallel lines and transversals is the converse true? What you will learn in this chapter is how to use the corresponding angles converse. We're not going to do constructions. I'm going to skip that. Prove theorems about parallel lines and use the transitive property of parallel lines. Let me do a strike through on that one item. Can't really do constructions on the video. I probably could, but it'd be very tedious. So we're not going to do construction in the video. So let's move on.
Okay, theorem 3.5, corresponding angles converse. First of all, what is a converse? Well, let me go back to an if-then statement. If it rains, then I bring an umbrella. The converse to that would be, if I bring an umbrella, then it's going to rain. So all it's taking is the if part and making it the then, or the hypothesis becomes the conclusion, and the conclusion becomes the hypothesis. In other words, we're working backwards. So if two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel. So the converse to that would be, if two lines are parallel cut by a transversal, then corresponding angles are congruent. You read it backwards. So it'd be, if the lines are parallel, then, or I should say, if two lines that are parallel are cut by a transversal, then corresponding angles are congruent. This one is, if two lines are cut by a transversal, so the corresponding angles are congruent, then we can prove the lines parallel. So it works both ways. Lines parallel cut by a transversal, corresponding angles are congruent. Two lines cut by transversal, and we know the corresponding angles are congruent, then we then can state the lines are parallel. Hopefully that made sense to you. It's just working backwards. We were given the angles were congruent. Since corresponding angles are congruent, the lines have to be parallel. If we were told the lines were parallel, and then we cut them with a transversal, then we could conclude the angles are congruent. There will be a proof on this on example 36 way ahead in the future on page 180. We'll worry about that when we get there. Okay, example 1. Using the corresponding angles converse. Find the value of x that makes the measure of angle M parallel to N. So what we're trying to do is, okay, well, if corresponding angles are congruent, then the lines must be parallel. So we have to assume they are congruent. So if this angle here corresponds to this angle here, then they must be congruent if the lines are indeed parallel. And that's what we're trying to do. Find the value of x that makes these lines parallel. In other words, I need a value for x that would make this angle 65 degrees, because if corresponding angles are congruent, and the lines must be parallel. So here we go. All we have to do is say 3x plus 5 equals 65 degrees. Okay, so there's our formula, if you will. There are no givens. Well, the formula would be, if this was angle 1 and this was angle 2, you'd say the measure of angle 1 equals the measure of angle 2, or is congruent. Actually, let me do that just to get familiar with this. So we'll get back to that. If you wrote that, that's fine. But I'm going to start this by saying, let's call this angle 1 and this angle 2. So I can say the measure of angle 1 equals the measure of angle 2. But before I even say that, I can say angle 1 is congruent to angle 2. We know these two angles are congruent if we're proving these two lines are parallel, or we want to make those two lines parallel. So angle 1 is congruent to angle 2. And by the definition of congruence, we can then say the measure of angle 1 equals the measure of angle 2. And then we substitute our givens. The measure of angle 1 is 3x plus 5. And the measure of angle 2 is 65. So I did substitution. And so in geometry, you use theorems to write formulas, and then you substitute givens and you simplify and solve using algebra. So now we're going to do that. We're going to do the subtraction property of equality, and that's going to get 5 over to the other side. And 65 minus 5 is 60. And then we're going to do the division property of equality to get rid of this times 3. And the 3's cancel, and I'm left with 60 divided by 3, which is 20. So when x equals 20, then I check it. Okay, so now I'm going to do my check. 3x plus 5. 60 plus 5. 65. That equals that. That checks. And therefore, x has to be 20 to make m parallel to n. After this example, you should be able to do problem numbers 3, 4, and 6 from your homework. All right, theorems. Here are some theorems. I made these a little bit larger so when they print, you can see them better. Theorem 3.6, alternate interior angles converse, states that if two lines are cut by a transversal, let's stop right there. I'm going to talk you through this. Okay. And let me make it a little thicker and let's make it blue. This is my transversal. Two lines, J and K, are cut by this transversal. So the alternate interior angles are congruent. Okay, so that's saying angle 4 is congruent to 5. So we mark them with one arc, which indicates congruence in geometry diagrams. So if that is the case, then the lines are parallel. So if alternate interior angles are congruent, then the lines are parallel. So we can prove that proves J is parallel to K. And that proof example is example 2 on page 140 when we get there. Theorem 3.7 states that alternate exterior angles converse if two lines are cut by a transversal. Again, I'm going to point out to you in color what the transversal is. The transversal is the one line that crosses the other two. K is not a transversal because it only crosses this line. J is not a transversal because it only intersects this blue line. The blue line intersects both of them, forcing it to be the transversal. So if two lines, JK, are cut by a transversal, so the alternate exterior angles, remember alternate means one on one side of the transversal, which is this one's on the left of this blue line, and one on the other side, which is the right side, which is right of the blue line. One is opposite sides of 8 to the blue line, and they're outside the two parallel lines. That makes them alternate exterior. This is my interior of two lines, and the exterior is outside. Okay, so if two lines are cut by a transversal, so the alternate exterior angles are congruent, then the lines are parallel. So if angle 1 is congruent to angle 8, then J is parallel to K. Okay, and then finally theorem 3. Again, where's my transversal? It is the one line that crosses two or more lines. That is the only transversal in this diagram. So it says if two lines are cut by a transversal and J and K are cut by a transversal, so the consecutive interior angles are supplementary, then the lines are parallel. So if the measure of angle 3 plus the measure of angle 5 equals, what does supplementary mean? 180 degrees. If the measure of angle 3 plus angle 5 equals 180 degrees, then J is parallel to K. And that's what this states right here. Alrighty, so there are 3 theorems. Let's move on. Okay, example 2. Proving. Oh, yes, my favorite proofs. Yes, the alternate interior angles, converse. Okay, I'm just kidding. I don't mind proofs, but I know many students struggle with them. But I'm going to do it anyway. It's an example in the book. I want to explain it. Prove that if two lines are cut by a transversal, so line G and line H are cut by this transversal, and I am going to continue to stress what a transversal is. It is important you know that. It is a line that intersects two or more lines. So G is not a transversal because it only intersects the blue line. H is not a transversal because it only intersects the blue line. And the blue line intersects G and H, so it is the transversal. Okie dokie. All right, so in this diagram, this arc and this arc here tell the reader that they're congruent angles. So we can use that as a given. We are given angle 4 is congruent to angle 5. We are trying to prove G, line G, is parallel to H. I am not going to mark these parallel now. You don't do that until you've proven it or proved it. Okay, so what do we know? Well, first thing we know is the givens. So angle 4 is congruent to angle 5. Reason, given. Now, looking at this diagram, what else can we get from it? Well, if you look here, I have a 1 here and I have a 4 here. They are vertical angles, these two. And vertical angles, by definition, are congruent. So now I can state that angle 1 is congruent to angle 4. And the reason is the vertical angles congruence theorem. Okay? So now I have angle 1 equal to 4. 4 is congruent to 5. We're trying to prove G is parallel to H. What is the next thing we can do? All right, well, now we have, what are we trying to prove? That the two lines are parallel. Vertical angles don't prove that. Alternate interior angles, let me go back to our theorems. Alternate interior angles converse. If alternate interior angles are congruent, then the lines are parallel. Well, in all actuality, angle 4 and angle 5 are alternate interior angles. We didn't even need to mention 1 congruent to 4, but it's okay if we do, because we have, if we said angle 4 is congruent to angle 5, then G is parallel to H because alternate, we could have said 4 and 5 are alternate interior angles, and since they're congruent, the lines are parallel. But in this situation, we can now say angle 1 is congruent to angle 5. And what kind of angles are 1 and 5? Well, they're consecutive angles. And the reason we can say 1 is congruent to 5 is, if you look here, hopefully you're understanding the transitive property. If 4 equals 5, notice 4 is equal to 5 here, or congruent to 5, and then here it says 4 is congruent to 1. Well, if 4 is congruent to 1 and 4 is congruent to 5, then 1 has to be congruent to 5. That is the transitive property of congruence. Okay, so now if 1 is congruent to 5, we can say G is parallel to H. Corresponding angles converse. Okay, but if I go back, we had the alternate interior angle converse here, 3.6. So really, we could have, right from 4 being congruent to 5, we could have just simply said G is parallel to H right here, and said alternate interior angles converse. Okay, so that could have been a 2-step proof. Boom, done. All right, so anyway, proofs. If you would like to practice doing these, numbers 11 and 12 are examples or exercises that relate to writing proofs. I wrote that in orange because it's optional. I did not assign it, but if you want to try it, those are the 2 to do. Okay, example 3, determining whether lines are parallel. In the diagram, R is parallel to S, and they've labeled it right there. Line R is parallel to line S, and angle 1 is congruent to angle 3. So you should label your diagram the givens. 3 and 1 are congruent. Okay, so what can we do with that? Well, it's all about the transversals. If I focus on this being my transversal, I have line angle 1 and angle 2 on one side of a transversal of parallel lines. So since line R and S are parallel, I can say angle 1 is congruent to angle 2. Okay, I'm not doing a formal proof because I would have had to have stated that, but I'm just saying it here. Since lines are parallel cut by a transversal, the corresponding angles are congruent, but I will type that. So I'm going to put here, corresponding angles are congruent. Okay, that's the reason for angle 1 being congruent to angle 2. Next step. This takes a little bit of thought. So now I know angle 1 is congruent to angle 2. And I know angle 1 is congruent to angle 3. So if we had a proof and I said angle 1 is congruent to angle 3 here, I can now see that 3 is congruent to 1, 2 is congruent to 1. So therefore, angle 2 is congruent to angle 3. And the reason for that is transitive property of equality. Okay. So since 1 is congruent to 3 and 1 is congruent to 2, then 2 must be congruent to 3. Beautiful. Because now what I can do is focus on line R being my transversal. So I'm going to choose this line here now and move it to here. This is now my transversal that I'm focusing on. R is a transversal to P and Q, and angle 2 is congruent to angle 3, and they are alternate interior angles on the line R. So now I can say P is parallel to Q. Okay, P is parallel to Q, and the reason being that is alternate interior angles converse. So if I go back here, alternate interior angles converse says if two lines are cut by a transversal and the alternate interior angles are congruent, then conclusion, the lines must be parallel. So that is alternate interior converse. Okay, alternate interior converse. So we just proved P is parallel to Q. After doing this, you should be able to do problems numbers 13, 14, and 16 on your homework. Okay, using the transitive property of parallel lines, theorem 3.9. Transitive property of parallel lines states if two lines are parallel to the same line, then they're parallel to each other. Okay, so that is the transitive property. And so here we have if P is parallel to Q. So we were given a conditional statement, if then. The hypothesis stated that P was parallel to Q. Okay, if P is parallel to Q, and then Q is parallel to R. Okay, if P is parallel to Q and Q is parallel to R, then P must also be parallel to R. Because if two lines, P and R, are parallel to Q, they're parallel to each other. Okay, another example of transitive. Okay, example 4 is a pretty clear way to explain the property, the transitive property. Using the transitive property of parallel lines, the flag of the United States has 13 alternating red and white stripes. Okay, 7 red, 6 white. Each stripe is parallel to the stripe immediately below it. So this red stripe is parallel to the white stripe. And this red stripe is parallel to this white stripe, and so on, and so on, and so on. Explain why the top stripe is parallel to the bottom stripe. So what we're trying to prove here is, let me just highlight this. How about I do it with green? So here is the top row stripe. What we want to prove is that if I moved it down here, it would land right on top because they're parallel. That is our goal. So what I'm going to start off with is, this is pretty tedious, so I'm not going to do the whole thing, but I could say, if this is line S1 at the bottom of this red, and line S2 is the bottom of the white line, then I could, and they are parallel, I could say S1 is parallel to S stripe 2. Okay, stripe 1 is parallel to stripe 2, because it says each stripe is parallel to the stripe immediately below it. It doesn't say it's parallel to every line or every stripe. It's parallel to the stripe right below it. So S1 is parallel to S2. That would be our given. And then I could say S2 is parallel to S3. That is also given. Agreed? Because 3 is immediately below 2. Now I can say, well, if you look here, I have S2 parallel to S1 and S2 parallel to S3. I could now say S1 is parallel to S3, and that is the transitive property of parallel lines. Okay, so I have now shown that 1, actually we were given 1 was parallel to 2. We were given 2 is parallel to 3. By the transitive property, I can now state that this red line stripe is parallel to this red stripe. This fashion will continue all the way down, and I'm just going to say this now. This would take a really long time to write out. I would then state that S3 is parallel to S4 because it's immediately below it. And since S3 is parallel to S4 and S3 is parallel to S1, then S4 is also parallel to S1 by the transitive property. Then you would say S4 is parallel to S5 because they're immediately below each other. And then since S4 is parallel to S1 and S5 is parallel to S4, then S5 is parallel to S1. And you keep doing this over and over and over until finally the last step you would say S sub 12, stripe 12 is parallel to stripe 13. The reason? Immediately below it. And we would have worked our way up and said that 11 was parallel to 12 before this for the same reasons that we've been doing. And now since S11 is, and actually this would have been S1 was parallel to S12, then we could say S1 is parallel to S13. So it would just be repetitive all the way down. The immediately below transitive property, immediately below transitive property, over and over. Okay, so if consecutive lines are parallel, they're all parallel to each other. Okay, this brings us to the end of chapter 3.3. Please do the exercises below if you haven't done them after the examples. Problems numbers 41 through 44 are also included in this set, and those are review of older material. Have a great day.